So we're going to be finding the time of death of Mr. Fies of an apparent homicide. So we know that at 6 the temperature of the body was 80 degrees Fahrenheit, and at 7 it was 75. We also know that at the room the body was kept in, the temperature was 70 degrees Fahrenheit. So the first thing we need to do is find the value of K, the decay coefficient. So what you do is we plug in what we know into the formula. So it'll be 75 equals 70 plus 80 minus 70 e to the negative k. T is time, so 6 to 7 is 1 hour. We can put 1 or we can put 60 minutes, and I'll do 60 minutes. Then you'll simplify this equation. So it'll be 5 equals 10e to the negative 60k. After that, you are going to divide 10 from this side and this side so that you can get e to the negative 60k by itself. That'll cancel out. 5/10 is also 1/2, so we can simplify that to 1/2 equals e to the negative 16k. Now, when we get this, we want to get k by itself. So what we do is we take the natural log of 1/2 and the natural log of e. So natural log of 1/2 equals natural log of e to the negative 60k. Natural log of e is 1, so we can just go ahead and mark that out, and we can take the negative 60k and move it down to the bottom. And natural log of 1/2, when you punch it into the calculator, is negative 0.6931 equals negative 60, okay, because we can just move that down. Now that we have this, what we do next is we divide by negative 60, so we can get k by itself, divided by negative 60, divide this by negative 60, and we get that k is 0.0116. Now that we found k, which is the decay coefficient, we take this number and we plug it into another formula so that we can find the time elapsed from time of death to time of discovery. So what you do is you can either do 80 or 75 first, and I think I'm gonna do 80 because at 6 it's closer to like when he died. So what I'm gonna do is 80 equals 70 plus 98.6, because 98.6 is the average human body temperature. So 98.6 minus 70 e to the negative 0.0116 t. Oh, you can't see that. Here, I'll read it. 80 equals 70 plus 98.6 minus 70 e to the negative 0.0116 t. So after you get this formula, you're going to simplify it. So subtract 70, so then you'll get 10 equals 98.6 minus 70 is 28.6, so 28.6 e to the negative 0.0116 t, because we're trying to find t. Now we're going to divide 28.6 from both sides so we can get e to the negative 0.0116 t by itself. We're going to cancel that out, 28.6. Now we have 10 divided by 28.6 equals e to the negative 0.0116 t. After we get this, we're going to have to try and get negative 0.0116 t by itself, so we're going to take the natural log of both sides. So natural log of 10 over 28.6 equals the natural log of e to the negative 0.0116 t. Again, natural log of e is 1, so we can go ahead and mark that out, and that'll become 1, and so negative 0.0116 t becomes the bottom. So when you plug natural log of 10 divided by 28.6, you'll get negative 1.0508, and that'll equal this, negative 0.0116 t. To get t by itself, you divide it by negative 0.0116, that'll cancel it out, and you divide this side as well, negative 0.0116. And so you find that T is 90.59 minutes. We can round this up so it'll be easier on us. So that'll be 91 minutes. We also know that 91 minutes is 1 hour and 31 minutes. Okay, now that we found T, we're going to try and determine the time of death. So, since the body was discovered at 6, and we find that T was the time, like how long ago he had died, we're going to subtract 1 hour and 31 minutes from 6. So 6 o'clock p.m. minus 1 hour, so that'll be 5, and 5 minus 31, so that'll be 4:29 p.m. And so that is the time of Mr. Fies' death.